A very good morning, everyone. We are from MSU College Sabah, and today we'll be doing our assignment 2 for our subject Basic Discrete Mathematics. My name is Syafienie, and I'm taking Diploma in Information Technology, and I'm on my semester 3.
Hello, my name is Dayangku Syafienie, and I'm taking DTM Diploma Technology Maklumat, and I'm on semester 1.
Hello everybody, my name is Lydiaretta Lim Lye Shyn, and I'm currently taking Diploma in Information Technology and currently on my second semester.
Okay, so today we'll be starting with the first topic. The first topic is the fundamental counting principle. So what is the fundamental counting principle? It is the rule used to count the total number of outcomes in a situation. So how would we do it? So it is stated if there are X ways of doing something and Y way of doing something, we can perform X times Y to get XY, which is the number of outcomes. So example 1, in a cafeteria, there are 5 types of dishes and 2 types of drinks and beverages. How many total of possible outcomes when we pair the dish and a drink together? So to get the total of outcome, we need to perform X times Y equals to X1. So 8X will be dish, the dishes. Y would be drinks, and beverages. And XY will be the dish and the drink. So, how many types of dish do we have? We have 5. So we have 5 types of dish. So X is 5. And how many drinks and beverages? We have 2. So Y is 2. So to get XY, we need to times X and Y. So 5 times 2 will get 10. So the total outcome is 10. Okay, so let's do a visualization. So there are 5 types of dishes. So 1, 2, 3, 4, and 5. And then each dishes will be paired with the drinks. How many drinks do we have here? We have 2 types of drinks. So every dish will have the possibility of pairing up with each drink. So we have a branch, 2 drinks. So this is X and this is Y. So this is Y. So as you can see here, for each branch there will be another 2 branches. And then on the last branch, it will symbolize as XY. If we were to count how many branches we have at the end, we will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so let's start with the second example. So there are 9 SCD clubs and 5 academic clubs. Each students are required to join 1 SCD clubs and 1 academic clubs. So how many possible outcomes are there? As we have done it before, X is, let's just assume X is SCD club, Y is academic club. XY is outcome. So how many SCD clubs do we have in the question? We have 9. So X is equal to 9. How about academic club? We have 5. So Y is equals to 5. So to get XY, to get the outcome, we need to times X and Y, which are 9 times 5, which is 45. Okay, let's visualize it. So we have 9 branches. And each branches will have another 5 sub-branches. And so on. So we know that each branches will have another sub-branch of another 5 sub-branch. So each branches will have 5. So if we were to multiply each branches, which has 5 sub-branches, we will get 45. And that's it for the topic, the fundamental counting principle.
Hello, I will discuss about the topic of probabilities. So, what is probabilities? Probabilities is if S is a finite sample space of equally likely outcomes, and A is an event where A event is S, when the probabilities of A is probabilities A, the event, equals to size of A over size of S. S is the sample space of equally outcomes. A is the event, the outcome of event. So the example 1, find probabilities 2 for the experiment of rolling a dice. So the event is 2 for the experiment of rolling a dice. So the sample space of rolling a dice is, so each sides of the dice, we know that it has 1 till 6. So the probabilities of 2, the event, is 1 over 6, because we only have 1 here. So let's go to the example 2. This is the example 2. What is the sample space S of all possible outcomes in rolling a pair of dice? So this is the outcome of the sample space, which is we get 36 sample space The outcome of the sample space is 36. So the next question is, what is event A that the numbers showing face up sum to more than 5? More than 5. So this is the event. This is the event more than 5. We back to the formula. Probabilities A, the event, equals to size of the event A over size of A sample space, which means probability of more than 5 equals to, here we can see more than 5, we get here we can get all of this. Which is the outcome of the event is 30 over 36, the sample space. So this is the probabilities that we can get for this event. That's it. So to the next example. So for the next example is, you flip a coin 2 times. What is the probability of not getting 2 heads? So this is the sample space that we get: head tail, head head, tail head, and tail tails. So the outcome of the sample space is we got 4 of the sample space. We also can use the complement rule, the formula of the complement rule. The formula is probability of not A equals to 1 minus probability of A. So the not A for this event is, so the event is not getting 2 heads. So the not event is getting 2 heads. So it's only have 1, which means P not 2 head. Equals to 1 subtract P 2 heads. It's equals to 1 subtract to 1 over 4, because this is the outcome of getting the 2 heads. We still can get 3 over 4. So the answer still the same. We can use the formula before, or we can use the formula of complement rule, but the easiest one is if we use the complement rule for this example. So let's go to the last example. Okay, for the last example, Jane toss a coin and then roll a dice. What is S, the sample space? So this is the sample space, which is we get 12 sample space, the outcomes. Suppose we have the following events. So we get 2 events. The event 1, event A head appears. Event 2, a tree appears. So what is the probabilities of A, the head appears? We have 1, 2, 3, 4, 5, 6. 6 over 12, which means 1 over 6. 2. What if probabilities of B, the 3 appears? We only get 2. 1, 2. 2 over 12, which is 1, 6. Okay, so for the probabilities not B means not 3 appears, so we subtract 2, which we can get 10 over 12, which is 5 over 6. Okay, for the probabilities of A and B, the head appears and 3 appears. We only get 1 over 12, because head and 3, there's only 1. For the probabilities A union B is, we can use this formula, probabilities A plus probabilities B subtract to probabilities A and B. So we can get 6 over 12 plus 2 over 12 subtract to 1 over 12. We can get 6 plus 7 over 12 for the probabilities of A union B. Why we must subtract 1? Because in probabilities A and probabilities B, we already count the H3. So both of them count H3 2 times. That's why we must subtract 1 over 12 to get this, the probabilities of A union B. So that's it for my topics, probabilities. Thank you.
So now we will go to permutation and combination. So permutation is used to arrange members of a set in a defined sequence or series. So it is classified as arrangement. So in permutation, arrangement is very important. So it is used for number code, which is 1, 2, 3, 4, and then letter code, which is A, B, C, or D, and so on. So for the formula, it uses NPR equals n factorial over n minus r factorial. Alright, so moving to combination. Combination is used to choose a group by taking some or all the elements of a set. So it is classified as selection. Alright, so it is used for objects, which is books, people, tables, and so on. So the formula used for combination is NCR equal n factorial over r factorial n minus r factorial. Alright. So before you guys do permutation and combination, you need to know factorial first. So factorial equals n factorial. This is called factorial. Alright, so for example, 2 factorial. 2 factorials will equals to 2 multiples 1. Okay. So 5 factorials equals 5 multiples 4 multiples 3 multiple 2 and multiple 1. 100 factorial, it is a big number, so you guys need to do like this. 100 multiples 99, multiples 98, multiples 1. So this is the example of factorial. Here, as you can see, NPR and NCR. So what is N? N means the total number, and R means the chosen number. This is total numbers and the value of the chosen numbers. Remember, yeah? P is for permutation, and C is for combination. Alright. Later we'll move to examples. So for example 1, which is permutation, you can see here we got 6 number, which is 1, 2, 3, 4, 5, and 6. So from the numbers above, how many 4 digits can be formed? Repetition of digits is not allowed. So we know here we use permutation. So we'll use the NPR formula, which is NPR equals to n factorial over n minus r factorial. So n, what is the total number of this question? So it is 6. So 6 factorial over 6 minus 4 digits factorial. So 6 factorial will expand it like this: 6 multiple 5 multiple 4 multiple 3 multiple 1. So 6 minus 4 equal 2 factorial. So the answer will be 360. That is for permutation example, and then we'll move to combination example. So there are 12 fruits on the table. If 7 fruits have been chosen from 12 fruits, how many ways can be formed? So we know it uses combination, so we'll use this formula. NCR equal n factorial over r factorial n minus r factorial. So the total number of fruits is 12 factorial. Alright. So the chosen number is 7 fruits. So r will be 7 factorial, and then 12 minus 7 factorial. So 12 will expand it. 12 multiple 11, multiple 10, multiple 9, multiple 8, multiple 7, multiple 6, multiple 5, multiple 4, multiple 3, multiple 2, and multiple 1. So it is very long. Alright. So 7 factorial, we just write it down here. And then 12 minus 7 equals to 5. Okay. So 7 factorial multiple 5 factorial. So the answer will be 792. Actually, you guys can expand these like above here, but it will be very long if you guys expand it. So we'll just leave them like this. Okay. All right. So we'll move to the last example. So this is the last example of permutation and combination. What if permutation and combination appear in the same question? So find the number of permutation and combination if n equal 5 and r equal 4. So we'll do permutation first. So permutation, the formula is NPR equals n factorial over n minus r factorial. So we know here n equal 5 and r equal 4. So n 5 factorial over 5 minus 4 factorial. So expand with 5 factorial, it will be 5 multiples 4 multiples 3 multiples 2 multiples 1. And then 5 minus 4 equals 1 factorial. Therefore, the answer is 120. So this is the answer for permutation part. And we'll move to combination. So combination, we'll use the formula of NCR. NCR equals n factorial over r factorial n minus r factorial. So n equals 5. R equals 4. So 5 minus 4 factorial. So just do it the same as permutation. 5 4 of 3 of 2 1. So 4, just write it down. And 5 minus 4 equals 1. So multiple 1 factorial. So the answer will be 30. The final answer, you guys don't really have these. Write this down. Therefore, permutation equals to 120, while combination equals to 30. So this will be the final answer of this question. So that's all for permutation and combination. Thank you.